Vitamins. Vitamins are chemically organic compounds that cannot be synthesized in adequate quantities by humans, and therefore they must be taken in diet. Now, vitamins are of two types, water soluble and fat soluble. The water soluble vitamins are soluble in fat and they are not stored in our body as they are excreted in urine, whereas the fat soluble vitamins are soluble in fat and they are stored in our body and they are not excreted in urine. And high quantity of fat soluble vitamin in human body can lead to some diseases, whereas the high quantity of water soluble vitamins are of no harm as they are excreted. The fat soluble vitamins are four vitamins, and they are vitamin A, vitamin D, vitamin K, and vitamin E. The water soluble vitamins are of two types, non-B complex and B complex. The non-B complex includes the ascorbic acid, that is vitamin C, and the B complex consists of energy releasing, hematopoietic, and other vitamins. The energy releasing category of B complex consists of thiamine, that is vitamin B1, riboflavin, that is vitamin B2, niacin, which is also known as vitamin B3, biotin, pantothenic acid. The hematopoietic category of vitamin B complex consists of two vitamins, and these two vitamins are very important, the folic acid and the vitamin B12, which is also known as scopolamine. The other category of the B complex vitamin we'll see in next session. In this session, we'll focus on the vitamin folic acid. Folic acid, which is also known as folate, it plays a great role in one carbon mechanism. What is one carbon mechanism? We'll see in few minutes. It is essential for synthesizing several compounds, and folic acid deficiency is most probably very common deficiency, and it is particularly found in pregnant women and alcoholics. Folic acid, also known as folate, plays a great role in one carbon metabolism, which is essential for the synthesis of several compounds. Now, folic acid deficiency is a most common deficiency which is particularly found in alcoholics and pregnant women. Folic acid is used for the formation of DNA. Now, how does it form DNA? There is a reduced and a very active form of folic acid known as tetrahydrofolate. It receives one carbon fragments from serine, glycine, and histidine. It transfers this one carbon fragment to the intermediates that helps in the synthesis of purine amino acids and thymidine monophosphate. The thymidine monophosphate is a pyrimidine nucleotide found in DNA. So basically, purine and TMP makes up DNA. Now, if there is no purine and TMP, there will be no synthesis of DNA, and this will cause anemia. Basically, there are three types of anemia. The nutrition anemia. The nutritional anemia consists of macrolytic anemia, the normotic anemia, and the microlytic anemia. In case of folic acid deficiency, there is microlytic anemia, which is also known as megaloblastic anemia. This results from the inability of the precursors red blood cells to further divide, as there is no DNA.